Okay, sixth period. I recorded this video last period while I was teaching it to first period, and it did not save, or it would not let me save. It said an error, so I am trying again. So if you hear my stats kids in the background, that's why, but they're supposed to be quiet, right? Okay. Anyway, all right, so two-dimensional figures. We said that two-dimensional was like flat. So these are the boring figures. These are not three-dimensional figures like a can of soup. That's a three-dimensional figure, but flat figures, so like squares and rectangles and triangles and circles. We're going to talk about those on the back side of this, and we're going to do formulas like for perimeter and area and circumference and that type of thing. So squares, rectangles, triangles, but also any polygon is a two-dimensional figure. So polygons are closed figures that basically are enclosed by any number of sides, as long as the sides are not rounded. So a polygon, this polygon's name is GHJKLN. You name a polygon by its vertices. So this polygon is a 1, 2, 3, 4, 5, 6-sided figure. Okay, I gave the names of the figures down here. 6-sided figure means that it is a hexagon. So this polygon is a polygon, but more specifically, it is a hexagon. Okay, you should know probably the first maybe 10 of these. So you should know that a 3-sided figure is a triangle, 4-sided is a quadrilateral, 5 is pentagon, hexagon. This one might not be one that you know. Heptagon, that means 7. Octagon, nonagon, and decagon. Okay, you should know all of those. Anything that's bigger than 13 or 13 or bigger is just called like a 13gon or a 26gon or a 48gon, whatever. If it's bigger than 13 or bigger than 12, I guess, then it's just whatever gon. Okay, so the sides of a polygon are named by the vertices that connect it. So like this is side ML. Okay, so on and so forth. This would be like vertex K. The vertices are where the two sides come together, etc. So they talked about polygons. A polygon is a closed figure. So they give us examples of polygons versus non-polygons. These are all polygons because they are enclosed. Versus like this one, he is not closed. He is not connected. Not a closed figure. Okay. Now, in addition to them not being closed, they cannot intersect. The two sides cannot intersect. Sides can't cross. So if you think of this guy as being two triangles together, that's fine. But if you try to say that this is one polygon in itself, you can't do that. Okay. This guy and this guy and this guy, the problem with those are that they have rounded edges. Okay. Rounded edges or rounded sides. And that is bad. You cannot have a polygon that has rounded edges. So even though we're going to talk about circles on the back side of the sheet, circles are not polygons. So, a circle is not a polygon. He is something different, okay? All the rest of the ones that we're going to talk about on the back side, square, rectangle, triangle, those are all polygons, okay? And then this guy is the last one that is a non-example, and he is not a polygon because the vertices of the sides have to touch, okay? So this side is intersecting my side here on the right at a place where it's not his vertex, okay? So that's kind of why he doesn't work. Okay, all of these shapes kind of look really funky, so, I mean, it just raises a red flag that they are not polygons, okay? Now, in addition to naming a polygon by its sides, you can call it either convex or concave. You've probably had convex, concave in, like, science class or whatever when you're talking about mirrors. Or think about it as like an innie versus an outie belly button. So concave is a, shut up. That's what I said this morning, and they're like, oh yeah, that makes sense. Don't laugh at me. So the vertex of a concave is on the inside of the shape here. So this is like an innie belly button. None of these are on the inside, so those are all outie belly buttons. Those are all convex. Okay. I have weird analogies sometimes. It's okay. So anyway, they'll remember it now because they'll remember it as an innie or an outie, okay? So concave, the figure is caving in. Convex, it's like all of the vertices are on the outside, okay? Now, we also have special types of polygons where we have equilateral. An equilateral is a polygon where all the sides are the same. So that would be something like this, where all of these sides are maybe like 5. All of the sides are 5 in an equilateral polygon, okay? And an equal angular, that is where all the angles are the same. So, like this angle is the same as that one, which is the same as that one. Now, does it have to be true where an equilateral, where all the sides are the same, also has equal angles? Okay, so we'll think about what it looks like if all of the sides are the same, but not all of the angles are the same. Is that even possible? Do all the angles have to be the same if all the sides are the same? Well, let's think about this guy. This one, this one, this one, this one, this one. Let's do this and this. Let's say that all of those are 5s. All the length of those are 5s, all the way around, okay? This angle is not going to be the same length as this one, right? Or even this angle right here. That's a reflex angle. That's bigger than a 180-degree angle, okay? So those will not work. Even though the sides are all the same, it is equilateral, but it's not equal angular, okay? So that's that. All right, when you have a polygon where it's both equilateral and equal angular, it's called regular. So an example of a regular polygon is this one over here. This is a regular pentagon, and that pentagon is named A, B, C, D, E because of the vertices, okay? So all of the sides and all of the angles are exactly the same measure, so he is regular. Now, that is as opposed to calling him an equilateral equal angular, right? You don't want to name him 2 names, so we give him a special name. Equiangular. So instead of calling him an equilateral equal angular pentagon, he's just a regular pentagon, okay? We say that word regular a lot of times in like, just hidden in like maps testing, or like on the ACT they'll say this is a regular figure. Well, crap, I don't know what regular means. Regular means all his sides and all his angles are the same. So they'll sneak that word in there, and that really is telling you a lot about your figure, and you don't even know it. So regular figures. All right. So what they're wanting us to do for A and B is name each polygon by its sides, by convex or concave, and they want to know regular or irregular. So there's 3 names that we have to give it, okay? Now, if it's not regular, it's irregular. So if one of those sides or angles are not all the same, then it is technically considered irregular, okay? Now, when I name these, I give a first name, a middle name, first, middle, and a last name. First name, middle name, last name. The first name, let's start with the last name. The last name that I give it is by the number of sides. Number of sides, okay? The first name that I give it is regular or irregular. And the middle name is convex or concave, okay? So I list them in that order because otherwise it sounds funny, and I'll show you why here in just a second. So A has, let's start with the last name first. So his last name, he is a 6-sided figure, so he is a hexagon. 6-sided figure, he's a hexagon. Okay, let me scroll down. Hexagon, okay? That's his last name. His middle name, convex or concave, he is caving in right here, so he is a concave. Okay, and his first name, even though the sides are the same, and I know that the sides are the same because of these little tick marks, so all of those sides are measuring the same, the angles are not, and I can see that because this is labeled with 1 little tick mark, and this is labeled with 1 little tick mark, so those are the same, but then these are 2, which means that these angles are not the same as those 2, okay? So all of my sides are the same, that's great, but all of my angles are not. So even though he is equilateral, he is not equal angular, which makes him irregular. So he is an irregular concave hexagon, and I named him first, middle, last name in that order because it would kind of it would be kind of funny if you named him a concave hexagon irregular, or a hexagon concave irregular, or any other order besides that, right? Maybe you could get away with saying a concave irregular hexagon, but I just think it flows better in this order, right? That's because, if we go to English class, hexagon is a noun, and these are both adjectives, right? Irregular is an adjective, and concave is an adjective. So we want to make sure the noun is listed last, right? We want to give two things that describe our noun. So we always list the last name as the number of sides because that's a noun, okay? All right, so let's skip to part B. I'm going to switch colors. So let's start with the last name, if that helps you. Start with the last name. This is an 8-sided figure at the stop sign, so it is an octagon. Octagon. let's say his middle name is convex or concave. He is convex because he's not caving in anywhere. And then regular, irregular. So all of the sides are the same. I can see that because of little tick marks. And all of the angles are the same because of little loops. Okay, and they're all the same number of loops, so we're good. So he is a regular convex octagon. Okay, all right, first, middle, last name, we're good to go. All right, backside. These four figures here, perimeter, circumference, and area, these four figures are the four that you should know already. Some of them you will know already. But these are ones that I do not give you a formula or a cheat sheet on the test. Okay, when we start to get to like three-dimensional figures, like if I say find the volume of this cylinder, I might give you like a cheat sheet where I give you the formula, right? But these are ones that you should know. So this first line is going to tell you the perimeter and area. So let's talk about perimeter for just a second. Whenever you have perimeter and you find the perimeter, he is only labeled in whatever units he's in, right? Versus area is that units squared, right? So maybe it's inches squared or centimeters squared or whatever. So area is always labeled squared. Perimeter, or for a circle, it's not called perimeter, it's called circumference. And that is just labeled in units, okay? So whatever the units it's in, inches, centimeters, whatever. So unit or circumference or perimeter is only ever labeled in the units that it's in. Area is units squared. Okay, so let's start with talking about a square or a rectangle. Okay, the perimeter of a square and the perimeter of a rectangle are found by just adding all of the sides together. All the sides, all the sides. Okay, now they've come up with a better formula for perimeter for a square, because if it's truly a square, that means all of the sides are the same. Like maybe they're all 2's, right? So rather than taking 2 plus 2 plus 2 plus 2, the easier way to do it would be multiply 2 by 4, because there's 4 sides that are all 2's. So they call it 4s in the formula. I am a little fuzzy. They call it 4s in the formula. So you're more than welcome to add up all the 2's if you want to, or you can just take 2 times 4. Okay? For a rectangle, maybe this side is 3 and this side is 2. Okay? Well, then think about what the other 2 sides are. If this one's 3, then this one also has to be 3. And if this one's 2, this one also has to be 2. Okay? So if I'm trying to find perimeter, I have basically 2 sides that are 2 units long. That's like the 2L. And I have 2 sides that are 3 units long. That's 2 of the other ones. So I could take 2 times 2, which gives me 4, plus 3 times 2, because there's 2 sides that are 3's, and that gives me 6, so that my perimeter would be 10. Okay? So you're more than welcome to add up all of those together if you want to, but I usually just add up these 2 and add up these 2. Or another way of doing this, if you like it this way, if I add 3 and 2 together, that's 5. Well, this is going to also be 5. So 5 times 2 is 10, right? So I can think about it that way also, all right? Now, area of a square and a rectangle are going to be both the same. It's length times width, or some people prefer base times height, but it means the same thing. So if the base is 3 and the height is 2, then that area would be 6 units squared, okay? Now, for a square, the reason why they write it as s squared is because your base and your height are both the same dimension. So it's like taking 2 times 2, which is like 2 squared, right? So they just write it as s squared. So if it helps, just think about it as base times height, which is fine. Or for a square, since they're both the same, you can call it s squared, okay? All right, let's bump back over to triangle. So a triangle, if I think of just like a box or a rectangle, to find the area of that, it's base times height. But a triangle will be half of that. So to find the area, I take half of the base times the height, right? Half of the base times the height. Now, this triangle is one that's really funky. He's not like half of a box, but he still has the same formula. Your height is just measured as this vertical height that's straight down, right? He is perpendicular to the base. He has to be at a 90-degree angle with the base, otherwise he is not the true height, right? C is not at a 90-degree angle, and neither is D. So you can't just use that as the height. The height has to be the perpendicular height. Now, I asked them this morning, like, you have a triangle maybe sometimes that looks like this, which is really ugly. This is an obtuse triangle, where it's got a really big angle. So this is the base, right? Where's the height going to be located? Okay, this is the very highest point, but he needs to be perpendicular to the base. So sometimes you'll see him looking like this, where he comes all the way down, and he comes over. This right here is technically your height, because that's the height that's perpendicular to the base. It's just off the figure, right? So that is your height. You'll have to take that into consideration. So those are kind of weird shapes, but that is truly your height. And the base is just from here to here, right? That's the only length of your base, all right? So don't let that trick you. And then to find the perimeter of a triangle, it's just adding up all the sides together. Okay, go over to circumference and perimeter. So circumference, there's a formula for circumference, and it is 2 times pi times the radius. The radius is just from the center to the outside, so that long, or sometimes they will give you the diameter, right? 2 times pi is the same thing as the diameter, right? So I can either go 2 pi r, or I can go diameter times pi, okay? And both of those mean the same thing. So it's just kind of dependent upon what you're given. If you're given the radius, do 2 pi r. If you're given the diameter, do diameter times pi, and that's fine, okay? Now, the area is pi times radius squared. So you square the radius, and then you multiply it by pi, and that's the area. I have a lot of people get those two confused or switched around, like which one is circumference, which one is area, okay? Well, think about area. Area, you do your units squared, right? When you're labeling area, perimeter or circumference is just in units, right? So the square goes with area because it's in units squared. So pi radius squared, that's what you need, all right? So let's go down here. Let's find the perimeter, circumference, and the area of each figure. So this one is a rectangle. P is only going to be perimeter. Since over here this is a circle, the equivalent of circumference or of perimeter is circumference, so we're going to call it circumference on this side. And then we need to find area of each. Okay, so this rectangle, if I'm trying to find the perimeter, this bottom side is 3.2, then this side is 3.2 also. This is 2.1 and this is 2.1. So I add up all of those sides. Really, I can do 2.1 times 2 because there's 2 of them, so that's 4.2. Okay, 3.2 times 3.2 is 6.4, and if I add those together, okay, that gives me all 4 sides. That's 10.6, and that is in centimeters. Okay, so 10.6 centimeters, and I don't square it. It just looks like that. Okay, for area, I'm going to multiply my base and my height together. So 3.2 times 2.1, and I gotta look at my cheat sheet because what did we get this morning? I don't remember. 6.7 something. 6.72 is what you get. 6.72 centimeters squared. Okay, that's what he is. Okay. Part B, if you want to find the area, or excuse me, the circumference, we take 2 times pi times the radius. Okay, since the radius is 3, we stick 3 in for the radius. That's 6 pi. Really, 6 would be the diameter, right? If we would go all the way across here. So 6 pi, and if we take 6 times pi, don't use 3.14. Don't type in 3.14 in your calculator. You should be able to find your pi button. If you can't find your pi button, ask somebody else or ask me tomorrow, and I'll help you find your pi button on your calculator. But don't ever use 3.14 or your rounding will be off. So if we take 6 and multiply it by pi, we get 18.85 inches. Okay, that's circumference. All right, and then area, we do pi times the radius squared. Again, my radius is still 3. So I do pi times 3 squared, which is 9 pi. 9 pi. And 9 times pi is 28.27 inches squared. Okay? All right, so make sure you're labeling correctly how you're supposed to be. There's formulas. These should be pretty easy, but make sure that while you're doing these, you're in the process of kind of memorizing these formulas if you don't already, because you will not be able to use them on your test. Okay, these are ones that you should just know. All right, so example 3, Yolanda has 26 centimeters of cording to frame a photograph. Which of these shapes would use the most or all of the cording and enclose the largest area? So a right triangle with each leg that's about 7 centimeters long. So we have a right triangle that looks like this. Okay, and the legs of a right triangle are both going to be 7. So those are the legs. Legs as opposed to hypotenuse. So we're talking about legs, this is hypotenuse. So the area of a triangle is base times height divided by 2. So this would be 49, or 7 times 7, 49 divided by 2, which is 24.5. Okay, well 24.5 is pretty close to 26, but let's see if we can get it closer. Okay, so instead we're going to do a circle with a radius of about 4. Okay, so radius is 4, so we want to find we're going cording around the frame. So does that mean we're finding area or circumference of the circle? If we're going around the circle, then that means we're finding circumference. So we need 2 times pi times r, and if the radius is 4, then we need to figure out what 8 pi is. Okay, let me get my calculator. 8 pi. 25.1, so that gets us a little bit closer. 25.1 centimeters. Okay, so that's even closer than what this one was. Okay, so it's not A. Which one would use most or all of the chording? All right, so it's not A, we're closer with B. All right, C, a rectangle with a length of 8 centimeters and a width of 4.5. So length is 8, width is 4.5. This is what he looks like. Okay, and we want to find perimeter of that. All right, so then this is 8 also, and this is 4.5 also. So if I add the two 8s together, that gives me a top and a bottom that looks like 16. 4.5 and 4.5 give me 9. 16 plus 9 is 25, okay? 25 exactly, so that's 25 centimeters, all right? So I have 25 centimeters, but 25.1 centimeters is closer. So we're going to cross out C. We're still closest when we have B. And then a square with sides that are each 6, okay? So square with sides that are each 6. Really, to find the perimeter of that, we can take 6 times 4, which is 24, okay? 24 centimeters, right? So that's still not closer than B. So B is going to be my best option because B is going to use the most of that 26 centimeters to frame. So I would get the most circumference out of a circle picture, a circle photograph that has a radius of 4 centimeters. Okay? All right, now last one down here. Find the perimeter and area of A, B, C, D with vertices, and I want to know -1, -1. Here's A. B is at 2, 2. Here's B. C is at 5, -1, and D is at 2, -4. Oh yeah, oh yeah. C, D. So here's what he looks like. He looks like maybe he is a square, but we'll have to find out for sure. So what we have to do here, yikes, is we have to do some distance formulas. Okay, so let's do some distance formulas, and let's first go. Let's find this distance right here, AB, and then we'll find the distance of BC. Okay, let's do that first, and we'll see what we get. All right, so AB, BC. All right, so we want to find the distance from A to B. So distance formula is this guy. If you forget him, you're taking x2 minus x1, y2 minus y1. Okay. So if I want my second x coordinate to be 2, I take 2 minus a -1. 2 minus -1. Okay. Same thing for y2 minus y1. So 2 minus a -1 again. Say hello, Erica. You'll watch this eventually.
Hi.
Erica's watching
you.
too. Yes, yes. Hold on just a second, and I'm recording. Are you in there right now?
Yeah.
Tell them I'll be in there in like 2 seconds.
Okay. That's my time.
Perfect. Okay. So 3 squared is 9 plus another 9, so that's the square root of 18. Okay, so let's just leave him as a square. Well, no, let's convert him to a decimal. Let's do the square root of 18. Second square root of 18. Okay, so 4.24, let's say. Okay, now let's do the same thing for BC. From B to C, we have the square root of this guy and this guy, B to C. So my second x coordinate we'll say is 5. 5 minus 2. And then I have -1 minus 2. Okay? And then I have the square root of 5 minus 2 is 3. 3 squared is 9 again. Plus, wait a second, -1 minus 2. That's a -3, but when I square a -3, it becomes +9. So that is also the square root of 18, which is 4.24. Okay? Now, I have, instead of writing them as the decimals, I'm going to go ahead and write them still as the square root of 18 and the square root of 18. That's those two sides, okay? So if we're trying to find the perimeter, I'm adding the square root of 18 plus the square root of 18 plus the square root of 18 plus the square root of 18 and adding those all together, which really is like saying 4 times the square root of 18. That's going to be my perimeter. And this is in units. 4 square roots of 18. Oh shoot, I guess 18 can break down. Oh, sorry. 18 can break down as 9 and 2. Okay, 9 is a perfect square. that goes into 18ths. So if I take the square root of 9, that's 3, and if I take the square root of 2, that's just 3 square roots of 2. So 4 times 3 square roots of 2 would be like 12 square roots of 2 units. Okay, so that's my perimeter. Then my area, I'm taking base times height. So the square root of 18 times the square root of 18. Okay? Now, I don't even really have to multiply 18 by 18 together, because if I have the square root of something times itself, that square root just goes away and is just 18. So this guy's area is 18 units squared. Okay? All right, so that was a lot of information. If I went too fast, feel free to backtrack and rewind a little bit, or pause the video, anything like that. So I hope this video saves. I really hope it saves this time.